And I wanted to ask you to please hold your questions until the end. The presentation will take between 30 to 40 minutes, and then we'll have 20 minutes of Q&A. Please remain muted and enjoy the presentation. Dr. Baghaei, the floor is yours.
Thank you, Wahid. Thank you for having me. Very excited to be with you guys. So as Wahid mentioned, I will share my experience through the process that we have been developing machine learning applications for computer vision softwares. And because I shifted from academia to university, I could see many gaps at the end of my talk. I will recommend, if you want to work in industry, how you can start working while you are studying your course, and hope you will find this helpful. So my journey, I started my MSc in Embedded Systems and Computer Vision 2016. As for my project, I worked with Macrima company to develop the microwave imaging system as my PhD thesis. Then I started my PhD in neuromorphic vision-based tactile sensor. And in 2017, I attended summer school. I published more than 4 journal publications during my PhD. I also collaborate with different research teams for game theory group. And I was teaching as well at the university. In 2018, I started working part-time at Ipsotech. They were having a video analytics company, and they wanted to use AI to leverage AI for their applications. And mainly we were 2 people starting this work at this company. Currently, I am AI product manager, and Ipsotech is acquired by Atos company, which is quite a large company last year. So I would like to start something that I see it's different in industry from academia. You read a lot of papers talking about AI success, but 87% of ML projects fail. This is published by VentureBeat in the different fields. And this is not even limited to computer vision only, it's for any ML project. But why? So we should know about machine learning. So machine learning is data-driven, and it's different from software algorithms because we take decisions, we train our models based on data. So data is quite valuable for machine learning projects. That's why a lot of shifts it's happening in different organizations to approach their data. And data is not enough because it's unprocessed facts, but by processing them, we can gain insights and make business decisions based on this data. So in 2020, there are some research that have been published that even more than 65% of time of data scientists goes through data, not algorithm itself. And that makes sense because machine learning and modeling are based on data. If you have a really bad and noisy data, you can't do much with your algorithm. So since 2019, we have seen a lot of organizations and universities talking about data-centric AI. And the reason for that is that if you clean your data, if you make sure that your data is appropriate for your application, you actually can get more gain from data rather than training different architecture or testing different architecture and algorithms. This means that it is very important to deal with the data and actually go through your data, trying to load your data properly, visualize it, and also clean your data. So this is one thing that I want to emphasize because most of students, when they join a company as an intern or as a junior, they forget about data. They just want to try different algorithms, learn new things. I understand that's exciting. But if you want to achieve good, reliable results, you need to make sure that you spend enough time on your data to understand your data and then train your models. So basically, three different roles are involved in this process. So when you have raw data, usually you will need a data engineer to deal with your data and bring it in a form that data scientists can use it. And data scientists, they will try to apply different methods to understand their data and process this data. And finally, data scientists with ML engineers, they will train a model and then deploy it into the product. So there is a cross-industry standard for the whole process. It's different from the software development process. This is more for data science and any data-related projects. So first, we need to, and this standard is called CRISP-DM. It's quite famous, and in many industries, they refer to these standards. So first of all, you need to understand the business. It is very important because when you are defining a project, you may miss the business point, and you may go and train a lot of different models which doesn't have business value. Then you need to understand your data. You may have really nice business idea, but collection of data might not be possible. So you shouldn't start this project because without data, you cannot train any model. Then after understanding of these two sections, you can start collecting data or from public resources with respect to the copyright, and prepare your data and start modeling. Then you evaluate your model and deploy your model if your model works well. For the evaluation, it's really important to define a metric. For example, there are so many tasks in the modeling that you may have different evaluation metric for your application. So for example, if you see a lot of papers or books using mean squared error for regression tasks, you need to rethink about this. Maybe in your application, you want to use mean absolute error. And this is very application specific and very important to choose the right one. If you want to go through details of this cycle, there is another AI life cycle called CDAC. And I really like this diagram because it shows almost everything. And I found it very useful that we went through the same process at Ipsotech to develop all the AI applications. So first of all, we need to identify and formulate the problem. After understanding the problem, we usually try different algorithms and pre-trained models to see if there is any pre-trained model on that and check the accuracy and probably find some biases and problems. Then we try to prepare our data, explore our data, going through data, visualizing, checking the statistic of our data. Then we try to approach external companies, partners to find out if we can use any external data. Then we clean our data. For example, if you're working with image classification and you collected a lot of videos, you may want to select few frames for training because if you want to actually train on every frame, it takes so much to train your model and it doesn't bring so much value. So you need to make sure that you select the right data for training. And that can be done by machine learning or statistical or even other algorithms even for selecting this data. Then after cleaning the data, we go through data augmentation. We try to understand what are the missing features in our data set and trying to augment those. Then we build an initial model. We developed a benchmark framework to benchmark all of these models and define our metrics. Also, we collect new data for test sets to actually benchmark it against test sets. Once everything is ready, we keep building multiple models with different parameters. For example, you can change a lot of parameters in your data augmentation. You can play with your data set. For example, your data set has multiple different annotation. You can exclude some of the annotations. You can include further annotations and build multiple models. After building multiple models, we evaluate each model and trying to investigate what are the strengths and weakness of each model. Recently, AI model explainability is added to this framework because after so many failures in AI that happened due to the bias in the data set, many applications recently require you to actually develop the AI explainability model to understand that your AI is learning the right thing. And this is depending on your industry. For example, this is very crucial in healthcare. Then after you develop such a metric, you evaluate on the explainability metric, all of these models, and then you select your model and work with software engineers and ML engineers to deploy it into the product. You need to collaborate with operations as well, usually because many models, they have different options and parameters can be set by the user. So they need to understand which parameters to set for your product. And finally, you can automate all of these processes, operations processes, and monitor and evaluation frameworks for monitoring your projects. The final step, sometimes I see that many engineers, they forget about is monitoring your system. If you awarded a project and your project has been successful, you need to monitor your system to make sure that your model is still performing well. Because so many projects, your data may drift, your model might age, and you need to retrain all of this model to maintain the accuracy. And it is very crucial, and it requires effort of all company in different sections to monitor these projects. From project scoping and business understanding, I created some questions that we usually ask. So first thing that I asked, how many models do I need for this project? Because sometimes you can solve a project with 10 models, but is this deployable in a server on your customer side? How do you want to approach it? Does it run on the cloud? Is it real time? If it's really real time, probably you don't want to use a lot of models because that makes it more slow and provide more latency. Then you will ask about the complexity of challenge. For example, in computer vision, if objects are occluded, it's very difficult to detect or perform other tasks. Or if light conditions are not appropriate for your application. So how do you want to solve that? Then you have dynamics in the environment. For example, your environment is not fixed, and usually these projects bringing a lot of challenges that you cannot think of, because if camera is moving, you don't know what to expect, and you cannot even predict what's going to happen with the camera. For example, a bird might sit next to the camera, and what you're going to do in that case. What is the expectation of accuracy? So does 80% accuracy, is that enough for your customer, or no, they want to actually reach 100% accuracy, which is not, for example, feasible in many cases? And can this problem be solved by other methods? So if you can avoid machine learning and solve a simple problem with statistics, there's no point to go through machine learning, for example, and training complex models for that. Is there any recorded data for the project that you can start with? And what are the minimum requirements around your data quality? For computer vision, for example, resolution of image is super important. Then you need to define about your strategy for data. So how do you gonna collect data, when to collect this data, how bias can affect your data collection phase, how long does it take, you need to actually estimate the cost for this project, quality of your data, is there any hardware specific thing that you can change in order to improve quality of your data? For example, computer vision uses camera. Can you change camera parameters and configuration to improve your image quality? Other sensors, you can change, improve the resolution of sensor or use different sensors. What are the external factors that can affect your data collection process? How can you increase your data diversity during this phase? And think about biases in your data sets. After defining all these strategies, you will go through your data collection phase, pre-process your data, store it, and if the task is supervised, you will need human in the loop to supervise annotation for your task. In computer vision, object detection requires, for example, supervised object detection requires bounding box around the object. And this will be done by human or by another AI model, which requires human to be in the loop to check these bounding boxes. Then after data collection, data processing, then annotation, we would like to design our training framework and choose the right algorithm or even create a new algorithm for ourselves, new architecture. So the first thing is, how do we approach the problem? In computer vision, for the same task, you can approach it as a detection. So you can provide these bounding boxes around an object, or you can approach it as a segmentation, which you classify each pixel, not bounding box anymore. You classify each pixel for each class, as you can see in the image. And you may want to actually define it as an anomaly recognition or key point recognition for the human body, for example. It depends on the application. But the crucial and important part is that you need to understand your data and your solution in order to make a decision on each model. I can provide you a task. For example, there is a task to detect birds on the ground. If you think of your data sets, you may collect a lot of data from birds on the sky and on the trees, but you may not be able to find any image or any video that birds are on the street, for example. But if you want to approach this problem with the normal detection or segmentation, you will face this problem that your model will be biased towards the sky because most of data that you have collected already are having a sky background. So these are important factors to decide. Should I do it from as an anomaly detection because I don't have enough data for example, for bird on the ground? Most of my data is on the sky. Should I do anomaly detection or should I do one class classification? So you need to make a decision based on your data. Then about the model architecture, I put accuracy at the end. It's quite important, but as I mentioned, data, it's a main factor for increasing the accuracy. Because usually you don't have a lot of flexibility around our model architecture due to the speed of your application. You cannot go through, for example, very deep transformers because you want high-speed application. Due to resolution of images, GPU power that you have, and compatibility. For example, for serving, you may want to use TensorRT. Your software engineering team are using TensorRT or other frameworks to serve your model. And you may find a paper that has really good accuracy, but they introduce a new type of layer in deep learning architecture, which is not compatible with TensorRT. So you need to actually take an account for these compatibility issues. And if you want to develop the compatible layers yourself, that may require so much time, and sometimes it's not even feasible to do that in different frameworks. And after deciding about the architecture, you train your model on GPU servers. And because usually you will deal with a lot of large data sets, these servers have multiple GPUs. You need to be good at training on Linux and with Linux environment, and train on different GPUs, trying to distribute your training and data loading code. Model validation and performance. So in model validation, very important to define metrics, test on unseen data. Never use your training or validation data for testing, because that doesn't make sense. Usually you need to test on unseen data and get insight from the results. You need to spend some time with your model to understand different biases and make sure your model doesn't fail in different environments. All these metrics, they try to quantify different behaviors, but when you play with your model and test it in different scenes or different data, you may find out different behaviors, because these metrics, they are trying to just quantify to one number rather than give you an explanation of behavior of your model. So very important to test your model on different data sets. Then, of course, model monitoring, it's very important to keep your model accuracy to high standards for your customers. I provide some useful tools for training. Usually in our industry, we use PyTorch and TensorFlow. Augmentations, it's very famous augmentation library for computer vision applications, and it's very famous and handful. AutoAugment, another augmentation library, which automates the augmentation process. Again, very useful library, and many engineers adopt this library. TensorBoard to actually monitor your training. And when you are training multiple models, you can monitor everything in real time, and it provides you some graphs around your loss and accuracy and other metrics. For computer vision applications, also we use usually OpenCV and Pilo for loading our data, playing with different algorithms to clean our data. For inference, most of the applications using TensorRT, NVIDIA TensorRT, and Torch, because they have model pruning, so they can actually prune your model to speed up your model and also quantize your model. For example, if you train a model with float 32, and you want to actually infer your model in very high speed application, you may want to quantize it to integer 8 in order to gain speed. And usually for real-time applications and fast applications, the serving algorithms are working on C++ and Java, while in training is mainly Python, as you are aware of. We have other frameworks for a specific application. So we have TinyML for embedded devices. Vitis, this library is developed by Xilinx, and this is designed for FPGA devices, if you want to work with FPGA devices. Useful repos in mainly computer vision, we have Detectron 2 It's developed by Facebook, and most of researchers, they commit their code inside their repo, so you can test different detectors. We have TorqueRec, which again, it's another work by Meta, and this is released recently for recommender systems. And we have PyTorch GAN, segmentation model, and ACME for RM. These are the repos that I really like them, and I saw many engineers using them. So you may want to have a look, and maybe it might be useful for your applications. It's very important, I think, to be aware of AI failure when you shift to industry, because more than 87% of projects will fail in industry. So if we are aware of different failures, we can to predict the failure and stop it before it's happening. So some of the famous popular failures from large organizations, the one is Tay chatbot. Microsoft introduced this chatbot in 2016, and after 16 hours, they shut down this chatbot on Twitter because it was feeding with a lot of racist and sexist content. And the reason for that was that they were training on Twitter comments, and some trollers, they were trying to push some data, racist data, and keep commenting on a specific post with racist content to actually make this robot as a racist or sexist robot. And it was a clear failure. After 16 hours, they shut down this robot. We had Filicar, which had an auto recognition tool to identify people. And sometimes it was identifying people as monkeys. Apple Face ID, first version of iPhone X, a lot of reports, even in one presentation, their facial recognition didn't work. Recognition from Amazon, it was tested on Congress, and Congress members' faces, they match with criminals' faces by mistake. And Facebook identify a person as primates very recently, it was a few months ago. Recruitment, again, Amazon 2015. It has a gender bias towards software engineering role. And a ball tracking system, it was a startup which they were trying to track a ball, and it was tracking the referee head instead of the ball sometimes. So you can see there are so many failures even for large organizations. Besides all of these failures, we have adversarial attacks. So in adversarial attacks, attackers, they're trying to create some noise or pattern, for example, in computer vision, to change the class and object. So for example, if you add this noise to the dog, your model may recognize the picture as an ostrich, which is not clear to human eye. We see this as a dog, but the AI model will fail. Similar thing can happen to Panda and other examples that you can see. Let's look at the main factors of failures in AI projects. So the most important factor is insufficient training data and do not having access to very diverse data sets. Over-promising in project scoping. So, for example, you have a project, you say, I can reach 98% accuracy without any research. And afterwards, you realize that you cannot reach that accuracy. Poor data governance for cleaning of your data. If data scientists, if they don't spend much time on data cleaning and data exploration, the model will fail. Lack of explanation of the model if you are approaching deep learning as a black box and if you don't understand what's going on in your data. Misalignment with business priorities, architectural complexities. For example, sometimes if you have multiple models that they are dependent on each other, one failure can fail the whole project. So very, very important to make sure that if you have multiple models working together, you need to evaluate them separately and together as well. Then hiring talent. So in US, 74% it has been 74% increase in AI ML jobs in last 4 years. And many companies are struggling to actually hiring talents in AI and ML. And many models are not efficient to be deployed. The model can have 500 billion hyperparameters, and it's not deployable easily on many GPUs. So some keywords for you, if you are interested in this field, if you want to continue your research, if you want to do your PhD. So these are the trends in industry as well as academia. Transformers and combination of transformers with CNN. Knowledge distillation. When you have two different models, you want to distill knowledge from teacher to students. Domain adaptation, which you have two different domains again, and you want to adapt the domain. Multitask learning, generative adversarial networks, explainable AI, transfer learning, federated learning, and fully homomorphic encryption in the training. So these are the main trends in industry as well as academia. That's I thought it might be useful to know these keywords. And if you are interested, you can read afterwards. Some advices finally, that's if you want to go to industry and start your career, try to contribute to open source projects in GitHub. You will learn about coding standards. You will learn about how to collaborate with software engineers and how to deal with the workflow that each repository has. Code versionings and different libraries that software engineers and data scientists are using. Attend hackathons and competitions on Kaggle and different websites. So you can see different approaches, different problems, and learn a lot from other data scientists and software engineers. Track requirement of jobs in each industry. If you are, for example, interested in game industry, try to track all the requirements. And if you have an assignment, you can actually use those tools and learn those tools through your assignments to be able to satisfy these job requirements in your field. And try to invest time on building a complete application. So if you are developing one model for one task, try to at least create a user interface for it, connect it to database, try to create the whole one complete application. Then you will learn how different software design patterns and also learn a lot from other to actually investigate different methods from different aspects. Yes, thank you. That's all.
Fariborz, this was a wonderful presentation. Thank you so very much. I'm sure if it was in person, we would be hearing a loud applause. Now, we're going to have at least 20 minutes of Q&A. I noticed that more than a few of the audience raised their hands during your presentation. They'll definitely get the chance to ask their questions now. I am going to invoke my moderating privileges to ask my very first question. Fariborz, you mentioned that data is of utmost importance in machine learning projects. In your career, how often did you have to deal with regulatory constraints or licensing issues? And is this something that you think data science students and aspiring machine learning engineers should be aware of before they start their career?
Yeah, I think very good point. So I was involved in a couple of projects, one in healthcare. through university, and it took, after going through different applications, it took us more than a year to get confirmation to access that data set for training our model. In the startup environment, if you are working for a small company, you need to be aware of, at least you need to be aware of different copyright levels. For example, if it's CC, if it's Creative Commons, we have different versions of Creative Commons. You need to make sure that you understand all of these different Creative Commons and which one you can use it for which application. Some of them you may want to use it for test only, but you cannot train your model on it, because the model goes to your product, and your product is the commercial aspect of the business, but the license doesn't let you to actually train your model, but you can test your model on it. So very important, but usually in large organizations, you have a legal and ethical team that they are in touch with you. And if you have any questions regarding the copyright of data and copyright of the software, they will answer your questions and advise you.
Very well. Thank you so much for that comprehensive answer. There's a follow-up question from my PhD student, Vivek, who asks, what are the ethical challenges you have faced in data collection?
Yeah, so in most of our applications, we are trying to, because we are video analytics company, and most of it in Europe, facial recognition is banned, for example, in public spaces. So we are trying to avoid a lot of critical application that requires to make sure that bias doesn't exist in your application. But for other type of applications, we had an ethical committee through Atos, and we have some challenges due to the environment of the camera, because we are a multinational company and our software should work across the globe. So we list down a set of actions to actually, in our data collection, to consider different race, different locations in different countries, to make sure that we minimize it. And also we have explainable AI after our training of our models to make sure that these biases doesn't exist in our models. And we try to keep it as balanced as we can to avoid these problems.
Excellent. Thank you so very much. I have many more questions myself, but I would like to open the floor to others to ask questions. Oh, wow, my PhD students are on fire today. Nancy Rose, my other PhD student, asks, is there a process of scrutiny libraries? Is there a process of scrutiny libraries have to go through to become an industry standard, or does anything go? Many small projects sunset, so dependencies breaking seems probable but problematic. Any thoughts or comments on that?
I think I didn't understand the question well. So in there's, okay, library have to go through to become an industry standard, or does anything those many smart projects sunset? So depends. It's very tricky. I think the only comment that I have is the going back to the large projects, open source projects. For example, one of the things that I think really helps in to understand different standards, it's looking at large open source projects and trying to be part of them. For example, PyTorch Lightning, PyTorch. These are very large projects. And you may find a lot of different libraries, dependency based on them, that is developed by students. And when you go through their process, because they're trying to be actually on top of the standards in industry, because they are open source and everyone can check their code. So they are very careful about the standards, coding standards, and different code quality aspects. So I think that's a useful thing to do to understand more about these type of applications. I hope I answered your question.
It was an excellent question, a tricky one, and I think you did a wonderful job in clarifying the situation, Fariborz, clarifying a very foggy situation. If you have any questions, please raise your hand virtually on Zoom or message me your questions. Bibek has another question. Since accuracy plays an important role in deciding the deployment of the model in the actual world, what is the general range of accuracies that tags the model for deployment?
Very tricky one. I think it depends on the application. As I mentioned, if you work in different industry, you have different standards. You need to think about the application itself from business point of view. For example, if the business might lose a lot of profit because of one person's misdetection or something like that, okay, in that case, it means that one person, it's a huge deal for that business. So you want to actually achieve really good accuracy. But in many projects, if I want to give some numbers, in many projects, if your data set is diverse enough and it's representative of your deployment environment, more than 90% accuracy in our projects was a good number for us to go through the deployment. And as I mentioned, you need to keep monitoring these 90% accuracy models to improve it, and also to make sure that you maintain this accuracy due to data drift or other factors.
Very well, thank you. And Ravina asks, which explainability techniques are commonly used in the industry?
Yeah, so my background is mainly computer vision. In computer vision, the common algorithm is GradCam, GradCam++. And we compare these two and perform it on different data sets as well as the test set to make sure that our model doesn't have bias. So how we do it is, I would say the algorithm is very important. Again, your data selection for explainability is crucial because you want to actually compare different models together on different data rather than if your data is not representative of your test set, your explainability would be very good. If you quantify it, you will get really high explainability and low bias in your model. But it doesn't work when you deploy it because your data was not representative of your test set. Yeah.
Very well, thank you. Fariborz, while we're waiting for the next question, I'm going to give you a short break from technical questions and ask you a slightly more personal one. I'm sure many of the aspiring data scientists and machine learning engineers in the audience are curious. What does a typical day at work look like for you? What do you do on a typical day at work as an ML tech lead?
ML tech lead. Okay, so yeah, so usually my typical day involves it has different aspects. So from technical point of view, we have requirements from different projects to train new models, new models for detection, for segmentation. So I actually go through these requirements, do a feasibility study about these requirements to understand if it's doable with AI, with our models or not, and define our data strategy, data collection strategy, sometimes even partnering with different companies for data collection, defining annotation guidelines. So if you are working on supervised tasks, you can annotate some data in many different ways, and that affects your model directly. So defining these annotation guidelines and parameters to annotate for the annotation, it's very important. So we should write the guideline about that. Then if we have a training framework we use that we have developed before, we just reuse those training frameworks to train new models and evaluate them. If the requirements require us to actually develop a new training framework with a new architecture, we spend so much time to actually improve our training framework and supporting the new architecture. Then, as I mentioned, data. I have colleagues, I have a couple of colleagues, we all together, we always look into our data. Even sometimes I have 2 hours, 1 hour of my day looking into different data sets that we have collected, looking into inside a statistic of those data. And for the evaluation of the models, we usually compare these statistics. We try to create a proper test set based on the insights we got from the data. And that's a typical day. Besides all of these technical tasks, I would say, a data scientist needs to be able to talk to different teams. And I think this is very important. And this makes data science a little bit unique in the software development environment, because identifying business problem, that's the first step. But you need to actually have a data scientist who can understand the business problem and say, okay, this is doable with AI or not, because sometimes it's not doable, and data scientists can understand these things. Based on the data, they can consider the data collection phase, the time that they need to spend. So usually you need to discuss it with business department, business developers. They're proposing a business opportunity to different clients. So they need to consult with you to understand if it's possible to provide this solution. Then for the deployment and operations, of course, after training your model, having your models in collaboration with all data scientists, you need to collaborate with software engineers and ML engineers to bring your model to the product. And afterwards, you need to actually go through operations team, because they need to work with your models and they need to understand these different parameters of your model. For example, threshold, what that means in your case. So it is quite common that I am involved in different departments for different meetings to decide about these crucial factors.
Wow, you have a very high entropy schedule on a daily basis, and it sounds like you never get bored. We have a question from Bryce, who asks, so in general, you want to pursue the greatest degree of accuracy possible? Is that the general goal in machine learning projects and engineering tasks?
It's not about accuracy only. It's about a balance of the first thing. You need to define your metrics. That's very important. So many applications, for example, you want to look at F1 score. Based on your application, you need to make sure that you define a right metric. I think that's more like an AI product management role, job, to define metrics for your application and tell the data scientist that for this business use case, this is what I want to achieve. And if we achieve this project considers as a success. So usually product managers will define these metrics for data scientists, and accuracy can be one of the most important one, but depending on the project, you may want to change it to F1 score. You may want to actually sometimes don't miss anything, but having low accuracy, for example, improving your positive, false positive doesn't matter for your application. It's very depends on the application itself. So I cannot say it's always accuracy.
Very well, thank you. Do we have any other questions? I'm gonna fill in with another question on mine, Fariborz.
Yeah.
First of all, the cycle that you were showing us, the 17 or 18 component cycle, it is a cycle. Why do we need to go back to looking at the business problem after monitoring and evaluating the model post-deployment?
Yeah, you mean the identifying, formulate the problems.
Yes.
That's so there are some missing parts here that you can consider. When you monitor and evaluate your performance, sometimes you may decide that this doesn't work. So if your application fails to deliver that expectation, you need to redefine your business problem and you need to formulate it again in order to have a clearer scope to approach it again. So if it's successful, usually you don't go through the business, identifying business opportunities again. But sometimes, again, we see opportunity, we bring new AI features in the product. We have customers that they are happy already with the solution, but with new features, we can provide new functionalities for their business. So we create bundles and go to the customers again, defining new features for them and say, look, if you, for example, if you, for example, use our new features, you can actually improve another aspect of your business. So we're defining multiple different problems for even one client based on features that we bring to the product.
That makes perfect sense. Thank you. Since we have no other questions, I'm going to still invoke my moderating privileges and ask a few more. Fariborz, I really appreciate your patience with us. We've been really enjoying the presentation so far. Oh, Suraj has a question. Suraj asks, how often can we provide security to AI and ML models? How often do you at work need to worry about the security of your ML models with respect to adversarial robustness, model privacy, model confidentiality, and so on? Is that something that the industry as a whole is generally concerned about?
Yeah, so model privacy, it's very important because that's the IP of the AI team. So we create models, we make sure that it's encrypted to the high-end level. Nobody can access it, just our software can access it, and cannot be, it's very important aspect. But from other point of view, like adversarial attacks, I would say it depends on the application. If, for example, you are dealing with autonomous driving cars, that can be very crucial because one adversarial attack in real world, one patch, for example, on the stop sign, which can change it to other type of signs, can lead to killing some people. So it depends on application. For our applications, because we are mainly using, we are providing on-prem applications for different industries. They have limited access to the servers, to the environment, to a lot of different things. So that's not mainly our concern that can be used against our models. But again, it depends on application. And other type of security issues, I would say anything that can reverse engineer our model, that is also very important for all businesses that they are using, they're developing AI. Because AI requires a lot of investment, data collection, GPUs, all of these things, time consuming, and it's costly. So once you train your model, you don't want this model goes anywhere else. So if somebody can reverse engineer it, it's not a good thing that can be happen. So very important for us from this aspect.
Very well, that's very enlightening. Thank you, Fariborz. Unfortunately, the very last question that we get the chance to ask is from our colleague, Professor Ardiana Sula, who asks, what are some of the common problems that result in project failures in your AI and ML engineering tasks?
Yeah, so the main common problem is that I would say bias in the data collection phase. So many projects starts with, okay, we have 8 terabytes of data, massive amount of data, so we can train the model to predict, for example, this task easily because we have access to data sets through last 3 years. Then after training, even some of these biases cannot be predicted. You get different behavior when you train a model and you test it, you understand that, okay, actually there is some hidden bias and some correlation between 3 different variables that you never thought of. And after training your model, once you want to test and deploy your model, you will test it and see these new behaviors and understand more about the bias. Sometimes you can collect more data and fix all of these biases. Sometimes we can use GAN, augment our data and fix these biases. But these are not always the case. And if you cannot find a way to fix the biases, and many projects, I think, fail due to lack of data and not being able to fix hard biases in the data.
Very well. Dr. Baghaei, I really want to be respectful of your time. We have more questions coming in, and I was wondering if the audience can reach out to you directly offline to discuss some of those questions. Would that be, would your time allow for that?
Yeah, that's fine. Absolutely fine. Audience can reach me on my email. I can share my email again after the talk, and I can answer all of these questions. Thank you.
Thank you, Fariborz. And before we end, is there anything that you think is absolutely crucial for the audience to know? Or in other words, are there any last words?
My last word is machine learning is data-driven. We usually forget about the importance of data in our application. So think about your data. Afterwards, you can think about your algorithm.
Fantastic.
Thank you.
Fariborz, Baghaei, thank you so very much. This was a wonderful presentation, very informative, and I'm sure all of our audience are very appreciative of your great presentation. Thank you so much. And
thank you.
Thank you to the audience. Have a great evening and have a great weekend.
Thank you. Have a great weekend. Bye.